Okay, this is CIS-125, and this was Wednesday, day 11, and this was October 5th, 10/5/16. We did a number of things in terms of, we reviewed from the quiz, we did the quiz review, and a number of other things leading into conditional. So first of all, this was the problem from the quiz. I had given all of this information here. I had done the information down here is where we have the questions, add to the legend. People should have added the diameter and the area. If you remember, this problem was we have a dowel rod, so it's circular, and we have the diameter and we had the length, and how much fabric would it take to cover the dowel rod. I'm not going to go back through all that, but we had the legend, we had pi, we have the length, we have circumference, and then the student should have added the diameter and the area. How to solve the problem was covered here. Okay, all the information in terms of the IPO. And then down here, we want to know what could be, right here, what could be used as initialization. And pi was probably the most common thing to do that. Then they were to design pseudocode. Okay? Some people, you can't mix these up. They said length was equal to x in the legend. No, you wouldn't do that. You know, if you want, I don't know what they wanted, but if they wanted x to represent the length, you could say, you could do that, and that means anywhere in the program you'll use x, but then they'd mix up length and x. You can't, you can't do that. Okay? So, up here, for example, area, diameter, I say what they represent. Okay. Next. Some other items in some other items that we talked about, either in this quiz or the previous quiz. There was a previous one I covered some of the main things. People should know that the operating system and utilities communicate with the hardware, and the application communicates with the operating system. That is important so that you understand that you either compile or interpret a program correctly for the OS that it's running on. When we refer in this class to data, we're talking about raw facts. We're writing code to process them into information. Some people said these are bits. Well, I hate to tell you, these are bits. And the programs that do this, they're also represented in bits. Everything in the computer is represented in ones and zeros. Okay? But the computer interprets, different things. It knows if it's a data file. It knows if it's a program file. And in a lot of cases, a program file will access the data and produce something of value, information. And information could be music, a video, a paycheck, a debit to an account or whatever. I mean, there's a zillion things the information can be. Alright, and so, key things in a computer: storage. Here's where the code resides. And then when you want to run the code, it's brought into memory. And then instruction by instruction, sent up to the processor, and results are sent back. In memory, there's places to store the information. in the first quiz too. Also in the first quiz, we talked a little bit here. High-level language, a human writes source code, they write the app, it's compiled, a compiler is software that takes that and makes it so some operating system can read it. It creates an object code from the source code. Source code always has an action word, so there's some command, so when it's put in the object code by the compiler, those commands are converted over to how the computer is going to function. And then link, some people looked it up online and got the wrong link. It looks at the library of code that exists for this particular programming language, like Python. For example, if you said import math, the math part's going to be brought in, the object code's going to be put with that, and then we get an executable code. Something considered to be low-level language. We go from high-level language to low-level language. Humans understand, the computer processes. Alright, this is just a repeat of the problem they had. We had a initialized pi. This was to find the diagram look like this, I believe. And then we had, in here we had the diameter and the length, and we were able to calculate how much material it would take to cover the dowel rod based on finding the circumference. Finding the circumference here, how far around this was, and then you could roll it out and you would have a rectangle then. So right along here was a circumference, up here's the length, so then if you multiply those two, you would have then the area of what you needed. So did here, we have input, the two things we need, length and diameter, found the circumference, area would be length times circumference, print it out, all done. So this would be your flowchart particular problem. I didn't write out the pseudocode, but the pseudocode would be, you could almost write identically what's in the boxes. You could write that exactly what's in the boxes for your pseudocode. Now on the assignments, what do you need? Well, you need all of that information mentioned in the syllabus for any document you turn in. You need to have some kind of definition of the problem, input-output process, you need to list that. Once you have those two done, then you can create a legend, start your flowchart, and a lot of times what would happen is as you're doing the flowchart, you will add to your legend. Once you get the flowchart done, it should be very easy to go through and create your pseudocode. Then you'll need some test data. I will give you some, or you could try some others, and you do a walkthrough. You check your design to make sure it gives us the right answer. Have somebody look at the design, and once you get all that done, you can now type the code in Python. Okay. Run the code, make sure it works, give the location of the code, and then have somebody else run the code and make sure it functions. So, every program, every piece of documentation you turn in will have all these things. It'll have this information at the beginning. You'll define it, you'll have an IPO, you'll have a legend, should be all easy and well labeled to find, flowchart. You'll have a pseudocode, you'll actually have the walkthrough there, and then you'll indicate that there was a peer review done on it. You'll list the actual code, you'll notice the peer review, the walkthrough and peer review comes before the code. And you can list your code in the documentation, you can list the run, where the code is located. Actually nowadays it's going to be 2 locations, going to be in your directory and then a copy of it in the group directory, and then you'll list who did a peer review to make sure your code functions correctly. Alright. A couple people had some issues with some variable names. All programming languages have reserved words. For example, you can't use the word print in a program as a variable. You can't use the word if in a variable as a variable in a program. And name is reserved, so you have to use something else. NAM $ maybe is a pretty common thing. Most people, old school, used to put a $ on there to indicate that it's a string of information. Okay, so if you're doing your coding and you run into an issue, for example, you can't use the word while, you can't use the word else, you can't use those as variables. Cannot use those as variable names. Alright. I was online and I was available Friday morning last week. You can always schedule a time if you have some questions. This shot is here to review the path of where your programs are. This part will always be the same. This computer, home, and then this would be your name, bin, and then the name of the program. Okay, and this would vary if you were listing where it is in terms of your group work. But you need to list your official copy where you've got it. So this would be your name, your directory, and this would be the file, the actual program name. Almost done. We covered some key things. If you want to rename a program, you can use, well, excuse me, if you want to remove a program, you want to delete it, be careful about doing this. Be careful. You can type RM and the name of the program and press enter, and that will get rid of it. If you want to copy it from one location to another, you can put CP, the name of your file, and then the directory where you want to copy it. And we have some examples of that. If you want to move a file from one location to another, you can do the same thing. Or this will also allow you to rename it by just using the remove, give the original name here and the new name here. Again, this was some of the information covered earlier about key things in the computer and the relationship of software and hardware. It's really important to understand that the app communicates with the OS and that utilities are also important. One more slide. This slide shows how we did a copy, CP, and then we had here, this was the file to be copied, and this that is where it was copied. So it took this file and made a copy of it in that directory. Okay? And I set up the rights to allow that to happen. And we'll talk more about those as the year goes on. Alright, so this finishes up week 6. Hard to believe, we're almost to midterm. make sure you contact me, the instructor, if you have any questions at all.